Okay. Okay, so this is just another example of how we can take first principles. So right now we're going to be talking about when we have two functions that are multiplied together, f of x and g of x. So again, in university, they're going to ask you to prove things using first principles. So you can see what a complicated proof this would be because you have two functions that are multiplied together. But by simplifying first principles, we get a very simple, well, it might look complicated to you, but when I explain this, it's a simple version. And you want to create something to help you remember this. So basically, to convert this notation into words, the derivative, if we have an f of x function, which I'm going to make blue, and a g of x function, I'll make that green, then our derivative, p prime of x, would be the derivative of the first times the original second function plus the derivative of the second times the original first function. So derivative of the first times the second function plus the derivative of the second times the first function. That might seem like difficult to understand, but if you had to go through the whole first principles process, it would take you so long. So it is kind of a shortcut that so we can bypass first principles and directly deal with our functions. Okay, I'm going to keep rewriting this formula throughout. So derivative of the first times the second function. So if we have something like this, where 3x minus 5 will be my f of x, and x squared plus 1 will be my g of x, that means f prime of x, g prime of x, in order to apply the product rule, I need these two derivatives. So let's say this again. The derivative of the first times the second function. That's what I'm talking about right here. The derivative of the first. Well, if I take the derivative of 3x minus 5, notice the negative 5 is a constant, so it becomes 0. 3x to the power of 1, when I bring the 1 down, that just becomes 3 times 1, and x to the power of 1 minus 1, which becomes x to the power of 0. So the derivative of the first function is actually just equal to 3. The derivative of the second function, x squared plus 1, well, I would bring the 2x and subtract 1 from my power. So the derivative of the second function is actually equal to 2x. So if I want to circle, I want to circle my derivative functions. Let me use this eraser tool. So the derivative of the first times the second function, sorry, I should make that blue. The derivative of the first times my second function plus the derivative of the second times my original first function. Once you've applied that product rule, now what do you think we're going to do next? Something you learned in grade 9. What was that called? Well, almost distributive property, because remember there's an addition sign here, and I should make that clear.
Sorry, sequence 2 for your attendance.
Oh, okay. Yes, it's on my desk. I'll be. Okay, so I'm applying the distributive property 3 times x squared, 3 times positive 1, 2x times 3x, 2x times negative 5. So after applying the product rule, it just becomes simplifying the fraction according to algebraic rules. So really that is the most difficult part, is simplifying based on what you've already learned, grade 10, 9, 10, 11. If, you know, that's where there will be holes on this test, if there's something missing from your prerequisite skill. The applying the derivative rules is the easy part. So we combine like terms here. Here we have a quadratic derivative equation. We already know how we can find the linear equation of the tangent line, but that won't be required for a question like this because it's just saying use the product rule to differentiate. Now on your test, I might not say use the product rule. I might just say find the derivative of each function. You have to figure out which rule to apply. This is a product of two equations. Use the product rule. I could use the power rule, but it would take longer. It would be more steps. But if you got the same answer, I would still give you the same marks. Okay. Over here, we have our f of x. And we have our g of x. So on the side, I'm going to figure out f prime of x. That's simple. 2x plus 3. The derivative of that using the power law is f is equal to 2. And for g of x, g prime of x would be equal to negative 1. So I have my negative 1, I have my positive 2, and I have my original first function and original second function. So I'm going to repeat my rule again. The derivative of the first function times my original second function plus the derivative of the second function times my first function, original first function. After this point, we have distributive property. 2 times 1 is 2. 2 times negative x is negative 2x. Negative 1 times 2x, negative 1 times positive 3. Then it becomes just combining like terms. Notice the original function was y is equal to, so the derivative is dy over dx. And that's it. So algebra. If you're strong in algebra skills, you're often strong with derivatives. Okay, here is a little bit more specific of a question and a longer product. We have a trinomial times a trinomial, and we need to find the derivative at x is equal to negative 1. So let's go step by step. Okay, so I have my f of x, and I have my g of x, right? My g of x is over here. My f of x is over here. Now this represents f prime of x, and this represents g prime of x. So notice we don't have a constant or a monomial because a trinomial gives us a binomial in the derivative. 5x cubed, if I apply the power law, that becomes 15x squared. 7x squared becomes 14x. Positive 3 goes away because the constant, applying the power law to a constant turns that into 0. 2x squared turns into 4x. Positive x turns into positive 1. If I had 4 terms and I was taking the derivative would be a trinomial. Here I have a trinomial, my derivative is a binomial. You'll see this pattern emerge as you are doing your questions. Okay, so once we get this equation, notice I'm not doing FOIL or any sort of expansion here. I'm leaving it the way that is because it didn't tell me to simplify the equation. It asked me at h, x is equal to -1 or h is equal to -1, what happens here, right? Find h prime of 1. So what I'm going to do is directly apply -1 into this equation. That makes things much more simple. That's not something I can do if I don't have an x value. In that case, I would have to simplify the algebra. When I have an x value, by substituting -1, you can see in these larger expanded brackets, we have 4 in total. Okay, not 4. Well, we have 3 large expanded brackets, and we can break that down into numbers. You can try that on your own, and it allows you to get the slope of the tangent line very quickly. So that's like a possible question in our third test of the course that we'll probably be looking at, but we could, it is in your unit guide, so we can give it to you part 1. We're just not there yet in terms of developing the test right now. And remember, I'm going to be posting PDF files of all of this, right? So just keep that in mind. I just want to be able to go through all of this with you. Now, this is a difficult question. Why is this a difficult question? We don't have the product of 2 terms. We have the product of 3 terms, but we can still apply the product law. And I want you to make sure to, you don't have to copy the question, but copy what's in the box over here. It says, consider x minus 1 times 2x, the simplest part of the equation. Consider that as the first function, and consider x squared plus 3 as the second function, okay? So if we consider this whole thing f of x, and let's say we consider all of this h of x, I'm going to call it h of x because the full function has already been called g of x, then f prime of x would be taking the derivative of 2x times x minus 1, which is 2x squared minus 2x. So the derivative of that would be 4x minus 2. Now, x squared plus 3 would be the second function. So g prime of x would be just 2x. So I do have the g prime of x over here, f prime of x over here, and the original function x squared plus 3, and sorry, I should have called that h prime over x. Let me fix that. So I want to call this h prime of x. And this is h prime of x. And my original f of x function over here. Okay, so that allows us to apply the derivative rule when we have more than one function. Yeah, no problem. So we have these 2 multiplied together and these 3 multiplied together. But notice that you can multiply the 2x times x minus 1 first to get a function, and then we can multiply or 2x times 2x to get 4x squared, and then we can multiply it by x minus 1, so we can do it in stages. But I just wanted to include this as an example of a more difficult function when we are applying the product rule. And this whole question, video or lesson is going to be on the product rule. Now it says, in this example, expanding the first would probably be easier, but that is not always the case. So it's expanding x minus 1 times 2x was easier for that particular function. But when you have something like 2x times root x plus 1, that is more complicated to expand. You get a lot more fraction exponents with fractions. So maybe in that particular case, if you had something more complicated, you would look to applying another rule, either the power rule or one of the rules we're going to be learning in the future. So a big part of the next two tests will be coming up with a strategy. What rule would be best for me to apply? Because maybe Nicholas is going to apply the quotient rule for a question and Selena will choose a whole different rule. You might both come up with the same answer, but Selena's question could be very short. Nicholas's answer would have to be very long based on what rule that you're applying. Okay, determine an equation for the tangent to the curve. So this is exactly what we did last time, except now we're not applying the power rule, we're applying the product rule. So I just want to show you how the methodology or the steps are still the same. First, we're figuring out the point on the tangent line. So we're taking x is equal to 2, right? I'm plugging it straight into the original equation. The original equation, not the derivative, the original equation to find a point on that curve to the tangent line. So when you do that, you get this point, y is equal to 3. So when x is equal to 2, y is equal to 3. That's a point on the tangent line. Now, in order to find the slope of the tangent line, because remember the equation, the linear equation of the line requires a point as well as a slope. I'm going to take the derivative of that equation. So let's label it. If this is f of x, then f prime of x is 2x minus 2. If x squared minus 2x plus 1 is g of x, then 2x is g, wait, sorry. Oh, I've got it mixed up. Sorry. That's why you have to be very careful, and maybe I should have read it from left to right, so I wouldn't have made this error. I read it from right to left. So I still have f of x, I still have g of x, but I have to remember this is f prime of x, and 2x minus 2 is g prime of x. X squared minus 1 is the original f of x function, and g, oh, okay.
Hey, good morning, everybody. Please pardon the interruption. Just before the first of the two dismissal bells. Today is Cohort C, as you all know. Cohort C, you will be back in this Friday. I would just want to make sure that if you have not already brought your materials from Quad 2 back into school, we really need textbooks, materials from all your courses that teachers provided to you in Quad 2. So we are going to ask you to please, Cohort C, bring your things in on Friday. We will have some locations set up on each floor, and your teachers will be providing you with sticky notes that you'll put your first and last name and the teacher that you were working with last quadrimester, and then you'll be able to deliver that on Friday. So folks, today when you go home, please scrounge around, find your materials, pack them up, put them in your knapsack so that you are, or a plastic bag, frankly, so that when you are ready to go on Friday, you're bringing all your materials back to school. I do believe that's it, everybody. I hope you have a great afternoon, and please don't forget dismissal is with the bell. Part of you are going for the first bell, and part of you are going for the second bell. Thanks, everybody. Have a great afternoon.
Okay, we'll be at the second bell. Okay, so instead of expanding and doing distributive property at this point, because I know I'm solving when x is equal to 2, I'm going to plug in x is equal to 2 straight into this equation because remember, the whole goal of this is to find the slope of the function. When I do that, and I do that carefully, the slope of the tangent line, not the slope of the function, the slope of the tangent line at x is equal to 2, because remember, along that curve, there are many different tangent lines. At x is equal to 2, the slope of the tangent line is equal to 10. So now I have a point on the tangent line that also is a point on the curve. I have the slope of the tangent line. I'm going to substitute that information into y is equal to mx plus b to find the equation of the tangent line. And this is what it looks like. The function, and this is why we do our functions course. I have a polynomial function here at x is equal to 2, y is equal to 3. That is a point on this particular tangent line, which looks like this, has a slope of positive 10. That's why it's a very steep slope. And the equation of that tangent line is 10x minus 17. So exact same steps we took last time, except before we were applying the product law, now we are applying, before we were applying the power law, now we are applying the product law. Okay, I'm going to include this in the notes, but it's just an example. It's not for the first test. It's just to prepare you for your unit work, as well as this is something that would normally be on our Unit 10 derivatives test. So the next two tests would be one test in a regular calculus course. We've broken it up into two tests because, of course, we're not teaching you the entire curriculum this year, and to manage your stress levels. But this would be a typical word problem where it sounds similar to grade 10. A lot of the grade 10 course word problems are going to come back into calculus. There's one test that's all word problems. And so they're going to sound familiar to you. This is about the student council raising money for an annual trip. So remember the whole equation of revenue, price times number of students. We are using our same strategies we learned in grade 10 to get a quadratic equation. From that quadratic equation, we are going to find the derivative, because whenever we're looking for optimization, which is a topic we're going to talk about later on in the course and is very relevant to all you students who want to be engineers, optimization needs this concept of at a particular or optimal point. So you need this strategy of the derivative. So here we have two binomials, 140 plus 10n and 200 minus 5n. Those are our original functions. I can code that in blue and green and blue. And our derivative function, so the derivative of the first function is 10. The derivative of the second function is negative 5. If I apply the derivative rules and simplify, I can get this linear equation. From that linear equation, I can plug in and find the derivative. When the derivative is equal to 0, that's one type of real world application problem. You are going to be able to review this on the PDF files extensively. But at different points, you're going to read through this. We are looking at maximum revenue, minimum revenue. So basically, we can take a word problem and use the derivative to extract real world application. So even though this is not going to be on the first test, I do want you to read through this so you can ask questions maybe next time. And I will probably start with this in our next lesson, as well as before I teach you about the quotient rule. So because the Ash Wednesday service interfered a little bit, what I might do is next time you come in class, focus on the quotient rule, but I'm also going to either give you examples live in person about power rule, product rule, and quotient rule, the three concepts you're going to need for the test, or I might just post those examples so you can ask us questions, because I will be, I believe, by myself No. I will, we'll have Mr. Bullock with me on Friday. So I'm just going to stop sharing there and